Hello, this is Ahmad Mirabi. In this video, I'm going to teach number theory a bit, and then I'll solve some practice questions. Okay, first of all, we need to know. In fact, it is elementary number theory. Okay, so what is a prime number? A prime number is a positive integer that have exactly two divisors. For example, 2, 3, 5, 7, 11, 13. What is a divisor exactly? Divisor is defined like this. Let me write it here. For example, if I want to know what is divisors of 12, they are composed of positive integers, so that 12 over x is a natural number or is a positive integer. Okay, so for example, these sets will be 1 and 12, 2 and 6, and 3 and 4. So there are 12 has 6 divisors. These are positive divisors of 12. We're thinking as divisor as positive divisors. Okay, so we're taking the positive integers, so that 12 over x is again a natural number or positive integer. Okay, so can I say that divisors of 4 are 1 and 2 and 4? Yes, so divisor is a number that if which divides this number into equal parts when no remainder, you will have no remainder. So when you have 2, it has 2 divisor, and you have 3, you have 2 divisor. They have exactly 2 divisors. And what's the composite number? The positive integers that have more than 2 divisors, like 4, 6, 8, 9. How many positive divisors does 9 have? For example, is 139 has 3 divisors, and for 4 it has 3 divisors again. So they have all more than 2 divisors. Okay, 1 is neither prime nor composite because 1 has only 1 divisor. Okay, now prime factorization. What is prime factorization? Prime factorization says every integer greater than 1 that is not a prime can be written as a product of primes. For example, 54 can be written as 2 times 3 cubed, or 12 can be written as 2 times 2 times 3, or 2 squared times 3. We can factorize the numbers like this, like a column. For example, 12, is it divisible by 2? Yes. Okay. Again, divisible by 2? Yes. Now, 3 is divisible by 3, and then we'll get 1. So 12 is composed of 2 2's and 1 3. So 2 times 2 times 3, or 2 squared times 3. Another way to factorize a number is like a tree. For example, 3 times 4, and then 4 is a composite number. It can be factorized further. So it is a product of 2 and 2. Now the final numbers at the end of the branches are prime numbers. So we'll get the numbers at the end of the branches. So 12 is equal to 2 squared times 3. This is called a tree diagram, or factorization in a tree form. This is the column wise factorization of a number. Okay, so here we've got 240. 240 can be written as 24 times 10, and so 10 is 2 times 5, and then 24 is 8 times 3. So we can write 2 to the 4th power times 3 times 5. Okay, so every composite number can be factorized into prime numbers. This is called prime factorization. Now let's do some example problems. What is the smallest number that must be multiplied by 300 to make a perfect square number? What are perfect square numbers? Perfect square numbers are like this: 1, 4, 9, 16, which means they are 1 squared, 2 squared, 3 squared, 4 squared. If we think of these numbers, and the prime factorization of these numbers will be everything is to the even power. So if, for example, A is a prime, B is a prime, let me rewrite it like this. For example, prime number 1 to n 1 power, prime number 2 to 2n 2 power, prime number 3 to 2n 3 power. So it means the prime factorization of a perfect square is like this: prime numbers to an even power. For example, 16 is 4 to the second power or 2 to the fourth power. So if you take the base, a prime number, the power is an even number. Okay, so based on what we learned is, so 3 times 100 is already a perfect square. So 3 times 2 squared times 5 squared. So the answer to this question is 3. What the smallest number that must be multiplied by 300 to be a perfect square is 3, because if you multiply it by 3, 3 will be squared here. Of course, we have greater numbers. For example, if you multiply this number by 300 again, it will be a perfect square, but we want the smallest such number. Okay, now here is a quantitative reasoning problem, or IQ problem related. We can solve it with number theory. Let's read it. Sarah has a piece of wood 8 centimeters wide. He divides it into 9 pieces. One of these pieces was a square and the rest were rectangles. So one of these is a square and the other 8 pieces are rectangles. Then he puts them together as shown and got a square. What was the length of the original rectangle? So it was originally a rectangle like this. So the width was 8, the length is unknown. For example, let me take it as x. The length is unknown, and we want the length of this triangle. But the area of this is equal to area of this. If we take this as t, this is t because it's a square, and it is clear that we can write 8x is equal to 5t squared, or 25t squared, because it is composed of 5 t's here and 5 t's here. The whole shape has become a square. Now the right hand side is a perfect square, therefore the left hand side must be a perfect square, which means you have here x, and you can have 5 squared times t squared. Okay, so x must have at least one factor of 2 and must have 2 factors of 5, because at the right hand side you have 25, so the left hand side must have those 2 factors of 5. And can it have more? Yes, it can have more, but whatever it is, it must be in the shape of perfect squares. It must be because right hand side is a perfect square, the left hand side must remain a perfect square. So this is 50. Can we say that x is a multiple of 50? No, not every multiple of 50. The multiples of 50, those multiples of 50, which is 50 times a perfect square. So the only choice is 200 here, because 50, this is 50 times 3, not acceptable. We said 50 times a perfect square. 50 times 4 is acceptable. And the other choice is definitely not correct. Okay.